Good morning, everyone. I'm Mohammad Kausar Hamid Miji. I'm studying computer science here at SD Mines. Today, I'm going to talk about Kerberos protocol. I will start my discussion with an introduction to Windows authentication, what kind of protocol it uses, its vulnerabilities. Then I will look into a high-level overview of Kerberos, its functional diagram, messaging format, advantages and disadvantages of the Kerberos protocol, and finally I will conclude this presentation and take your questions. Let's talk about authentication. Authentication is the process for verifying the identity of an object, service, or person. In a networking context, it's the act of proving identity to a network application or resource. For example, you want to access the D2L, you provide your user ID and password, which is authentication. Windows operating system uses different protocols such as Kerberos, NTLM, transport layer security, secure socket layer, and message digest protocol for authentication purpose. Before Kerberos, Windows used NTLM for authentication purpose, and NTLM has many weaknesses. For example, NTLM is vulnerable to brute force attack and pass the hash attack. NTLM also does not support the advanced cryptographic schemes, and NTLM is also works for single authentication, which means you cannot use multi-factor authentication for NTLM. Let's talk about Kerberos. What is Kerberos? So, Kerberos is a computer network security protocol that authenticates service requests between two or more trusted hosts across an untrusted network like the internet. Kerberos works in the client-server model and it is an application layer protocol. It uses TCP or UDP based on its implementation for data transformation. Kerberos was initially developed by MIT in the late 80s, but now it is maintained by Kerberos Consortium as an open source project. In 2000, Microsoft started using Kerberos as a default authorization technology for it, but Kerberos is also supported by other OS and used by them like Apple OS, FreeBSD, Unix, and Linux. Throughout this presentation, I will give reference to request for comment 4120. This is Kerberos Network Authentication Service version 5, but there is another dominant version that is version 4. The name Kerberos came from Greek mythology. In Greek mythology, the underworld lord Hades has a hound which guarded the gate of the underworld, and it had three heads and a tail. It had a bad temper, but here the three heads of Kerberos represents the client, the key distribution center, and the server. Before jumping to the functional diagram of Kerberos, let's talk about some definition of the components and terms. The first one is realm. The term realm indicates an authentication administrative domain. That means, say there is a realm X and under its jurisdiction we have database server. And there is a realm Y, under its jurisdiction there is file server. So the realm X will only be able to authenticate user for database services, and realm Y will only be able to authenticate people for file server related services. Principal is the name used to refer to the entries in the authentication server database. In the simplest way, it is the username that we use into log into D2L or Gmail account. A ticket is something a client presents to an application server to demonstrate the authenticity of its identity. The main information contained in a ticket includes username, ticket's max life, session key, etc. Consider that you are visiting a museum, so you need to purchase a ticket. That ticket will have how much money you paid, the date of your visit, and some other information. So you present it to the gatekeeper and they will let you in. Salt is a technique to protect passwords stored in a databases by adding a string of 32 bits or more characters, and then we pass it to a hashing algorithm. So salting prevents hackers who breach an enterprise environment from reverse engineering passwords and stealing them from the database. Key version number. So I am Miji, I have my password, but suddenly I changed my password. When I changed my password, this change is logged in by advancing a counter. The counter value, the current counter value of the counter identifies the key version is known as the key version number, or more briefly KVNO. The authentication server in the Kerberos environment is called the Key Distribution Center, or more in short KDC. It is logically considered divided into three parts: the database, the authentication server, and the ticket granting server, or TGS. The database contains entry for the users and services, which include the principle of an entry encryption technology and related KVNO, maximum validity duration for a ticket associated to the principal, password, expiration date, etc. The authentication server is the first one that replies to the initial authentication request from client when the user not yet authenticated must enter the password. In response to an authentication request, the authentication server uh, issues a special ticket known as the ticket granting ticket to the client. The ticket granting server. It is the component which distributes service tickets to the clients with a valid ticket granting ticket, and thus guarantees the authenticity of the identity for obtaining the requested resources on the application server. The session key. The users and the services share a secret key with the KDC. For users, this secret key is the key derived from their password, while for services, it is their secret key set by the administrator. So these keys do not change and called long-term. Generally, they do change based on the password management policy of the enterprise. But when a user access any server, there is a working session. So it is necessary that a user also shares a secret with the service, at least for the time in which the client has a work session open on the server. So this secret is generated by KDC when the ticket is issued and is called the session key. The authenticator. The authenticator consists of two information. One is the username or service ID, and another one is timestamp when the message is generated. These two are encrypted with the session key and sent with the ticket. So now we can look into the functional diagram of the Kerberos protocol. Let us consider that the client wants to communicate to the KDC for some service in the server. The client will send some message to the authentication server, and it will get reply from that. This kind of messages are known as authentication service exchange. In the same and After that, the client will communicate with the TGS, ticket granting server, for authentication purpose, and these messages are known as ticket granting service exchange. Upon receiving reply from the TGS, the client will be able to talk with the server, and it will get reply from the server whether it is approved for the service or not. This communication of the client server is known as client server authentication protocol exchange. Throughout the process, this Kerberos authentication process, there a lot of messages are being transferred between them, but I will talk mostly access request and replies from the client to the authentication server, client to the TGS server, and client to the server for the demonstration purpose and for a better understanding in the Kerberos protocol. The first message that the client sends to the KDC authentication server is the Kerberos authentication service request message. In this message, it includes the username, the service it is requesting, the service name or ID, and the IP address of the user and requested lifetime for the ticket granting ticket. This message is sent as a plain text. It is not encrypted with any key. So upon receiving this message, the authentication service server looks into the username, validates that this username with the database. So as a reply to the client, the authentication server generates two more messages and send it to the client, send these messages to the client. These are known as Kerberos authentication service reply message. And one message consists of TGS name or ID, timestamp when the message is written, lifetime, same as TGT, the client requested for TGT, and the TGS session key. This message is encrypted with the client secret key as it took a copy of the client secret key. It also generates another message that's called a ticket granting ticket. The ticket granting ticket consists of a username, TGS name, timestamp, user IP address, lifetime for TGT, and TGS session key. So the client does not know the TGS session key, but it knows the client secret key only. It also does not know the TGS secret key, so it will not be able to decrypt the second message. When the authentication server sends these two messages to the client decrypts the first message with its client secret key. Remember that the client has its password, so it adds a 32-bit salt to it and pass it to a hashing algorithm and generates the client secret key. With the secret key, it decrypts this first message, verifies the TGS name, finds out the TGS name, timestamp when the message is written, lifetime for the TGT, and knows about the TGS session key. Since it cannot decrypt the ticket granting ticket, it will send these ticket granting ticket to the TGS name that it obtained and generate some other message for sending to the TGS server. Now the client will send some other message to the ticket granting server for giving it a service ticket. So the client will send the ticket granting ticket that it received from the authentication server, and along with the ticket granting ticket, it will send two other messages. One message includes the service name or ID and requested lifetime for the ticket, and this message is not encrypted with anything, so it's in plain text, and it will generate another message that is known as user authenticator. The user authenticator message consists of username or ID and timestamp. So when the client sends these into the TGS, upon receiving these, the TGS will decrypt the ticket granting ticket first, because it knows the secret key of the TGS. It knows the TGS secret key. So when it knows the TGS secret key, after decrypting it, it will look for the username of the ticket granting ticket, match it with its database, and verify it. So when it decrypted the ticket granting ticket, it also received the TGS session key that is included in the ticket granting ticket. So with this ticket granting TGS session key, it will decrypt the user authenticator, and it will get the username of the client, and it will verify both username from user authenticator and the ticket granting ticket. It will verify the timestamp, it will verify the IP address of the user, TGS name, lifetime for the TGT, and other informations. So after verifying all of those things, it will do another work, that is it will maintain a TGS cache. It will look for any other available ticket, that is whether there is any other ticket available in its cache. If there is none, then it will add the user into its cache. So it will protect the TGS from replay attack. After that, the TGS will generate two more messages, and it will send the messages to the client for so that the client can communicate to the server for services. In its reply, the ticket granting server sends specifically two messages to the client. These messages are known as Kerberos ticket granting service reply message or response message. The response message, the first message includes the service name, timestamp, lifetime, service session key, and these are encrypted with the TJS session key that it received from the client through the ticket granting ticket. And another message that is called the service ticket, it includes the username or ID, service name or ID, timestamp, user IP address, lifetime for this service ticket. Previously, lifetime was for ticket granting ticket. Now the lifetime is for the service ticket that is generated by the TGS server, and the service session key, and it sends these messages to the client. Now, when the client receives these two messages, it knows the TJS session key, since it received the TJS session key in the as the reply from the authentication server. It can decrypt the first message with the TJS session key. It sees the service name or ID, life stamp, timestamp, lifetime, and the service session key of the uh, ticket. So then it doesn't have the service secret key. It knows the service session key as it get a reply from the TJS, but it doesn't have the service secret key, so the client cannot decrypt the service ticket. So now the client will generate more messages for requesting service to the server, and send those messages along with the service ticket for as a request for accessing the service. Now the client will generate another message. It has the ticket service ticket, and it will generate the user authenticator message. The user authenticator message includes the username or ID and timestamp. The client received the service session key as a reply from the TJS server, so it will encrypt the user authenticator with the service session key and send it to the server. Upon receiving these messages, the server will decrypt the service ticket with its service secret key. This service secret key is shared between the server and the KDC. So the server knows this service secret key and decrypt the service ticket, and it will find out the service session key. Since the user authenticator is encrypted with the service session key, it will be able to decrypt the user authenticator right now. So after decrypting these, it will match the username that is included in the authenticator and in the service ticket. It will look for the timestamp, it will match the user IP address, lifetime for the service ticket, and service session key. After doing all these validation, the server also maintains a cache, so it will look for any other ticket that is available in its cache for the specific user. If there is not any, it will add the username to its cache and maintain it to prevent itself from the replay attack. Then it will generate another message that is called as service authenticator and send it to the client for validation and seamless services. The service authenticator message includes a service name or ID and timestamp. It's known as the Kerberos authentication server response message, and this message is encrypted with the service session key. Then the server sends this message to the client. The client decrypts this encrypted message with the service session key. So how the client knows the service session key? The service session key is known to the client as it received this key from the ticket granting server as a reply. So after decrypting this service authenticator, the client will verify that the service name is the same service name that it wants to talk or access, and it will also verify the timestamp when the message is written. So along with these messages, we are seeing that for almost every message there is a timestamp. Kerberos is very sensitive to time, and all the servers need to be synchronized properly. So when a message is sent, then it will there is a timestamp, and if it is more than 2 minutes late, then Kerberos will discard the message. So timestamp is really very important. So after verifying all those things, Kerberos and by Kerberos protocol, the client will be able to access the server for its purpose. Now let's look into the message format of the Kerberos. The message size could be a few hundred bytes depending on the values of different fields. And these fields includes the KDC request, uh, protocol version number, message type, CNAME, PA data, name of the realm, sname, from, E-type, and encryption authorization data. Different flags like reserved, proxyable, proxy, post-dated, optional hardware authentication bits, and some other unused bits. It's not possible to talk about all the fields and flags. I encourage you all to read the RFC 4120 to know more details about those messaging formats. So let's talk about the advantages and disadvantages of Kerberos. Kerberos is superior than other authentication protocol used by Windows, as it provides client and services mutual authentication service. It is supported by different operating systems. The tickets in Kerberos have a limited time period, so if the ticket gets stolen, it is hard to reuse the ticket because of a strong authentication need. Passwords are never sent over the network unencrypted. And of course, Kerberos uses symmetric secret keys that are shared, which is better than a public key infrastructure. And it also there is some cons for Kerberos, like it is susceptible to password guessing attack, spoofing attack, and DOS attack, and it is also possible to compromise the KDC and verifier or server. I want to conclude this presentation. In this presentation, I wanted to draw a clear picture of Kerberos protocol, its working process, and the advantages and disadvantages of Kerberos protocol. Do you have any questions for me? Thank you all for your patience.